Hello, how are you? Thank you for joining me. Can you hear me? Good, I'm glad you can hear me. You're the first to arrive. I'm glad you showed up. I guess we'll wait a little bit before the rest of your classmates show up. Until then, do you have any questions? You're welcome. A lot of material this week, but thank you for answering the discussions. I saw your post there. You did a wonderful job, and you're off to a great start. It's a good idea to start tackling this material early in the week. So then if you have questions, you can ask them, or you just have more time to review it again. And it was a great example for the rest of your classmates. Thank you very much. Yes, and you're learning very well. You're going to be an expert when you're done. When you're done with your school, you'll know better than most people. Hello, welcome. I'm glad to see everybody starting to show up. Sometimes I wonder, I know what the time zone difference is, to make sure I'm in the right place at the right time. So when I see you showing up, then I know everything's good. We'll give it another 5 minutes. Give time for everybody to show up before I get started. Again, if you have any questions or anything you want to ask or know about, please feel free to do so. Also, you do have a microphone and a webcam if you want to put your video up or you want to speak, you're more welcome to do so. If not, type in the chat box, that's good too. Well, you have about 1 more minute, so hopefully more people will show up. This is a required session. It is being monitored to make sure you are here. So hopefully people will show up. And midway through, I will save the list of the participants to make sure then to give you credit for your attendance. Okay, it is on the hour, so I will start talking. And again, I hope more people will show up. I'm not sure why everyone is not here yet, but I'm assuming they will show up. If not, it's just you two. You're my dedicated students. You're here, and you're even here early. Okay, so I don't know. You know these other people. You're the classmates. Maybe text them real quick and tell them, come on over. Okay, slowly they're coming in. Hello, hello, everybody. Whoever's coming. Okay, thank you. Yeah, it's important, like again, it's important that you do attend these sessions. The ones on Wednesday are required. They are monitoring to make sure you are here. They really want you here. They really don't even want to give any substitute assignments unless there's extreme emergencies. So, good thing you're here. Okay, there is a lot of material to cover. This is a very complicated, or I shouldn't say complicated, but a very entailed chapter. Most of it is because operating systems in general are very sophisticated programs. As a result, there's a lot of complexity to them. So when you are learning about them, you have to understand and learn all this complexity. It's just the nature of what it is and what it does. I mean, it runs a computer, so we could use it. In the older days, when computers first started, it was very, very simple. But now, since we are using the computer to do many things, and also our technology is getting more sophisticated, that means the operating systems have to keep up and be just as sophisticated. Actually, I mean, the technology is more sophisticated than the operating system. We already know. The CPU can process so fast, faster than the program or the operating system can even get the instructions to the CPU. So, you know, there's a great demand for operating systems to keep researching and developing and meet the new technology that's out there. But it's a little lagging only because, as you're seeing for yourself, when you're looking at operating systems, they are sophisticated. There's a lot of issues that need to be addressed. And also, you got to make sure things don't crash. Nobody wants to use a computer. All of you, I'm sure, if you had your computer crash, you're not happy. And that is because there's operating system issues. And so you have to be very careful when you design operating systems, or even if you use it. If you change settings for operating systems, it can cause a problem. That's why most operating systems will come with something called a system restore. And what that does, it allows you to go back in time for when your operating system was working properly, in case you made some changes, in case you downloaded something. There's a lot of, you know, hackers that are out there that are trying to access and change operating system settings. So there's a lot of things that you need to address. And as we're learning the operating system, we're learning this complexity. However, I have faith in all of you. I know you will understand it. You will take away from this a good, deep understanding of operating systems. And that's what everybody should have and should know. There are many computer users out there that don't understand how their computer is working. And I think if they had that understanding, there would probably be less problems. They won't change settings by making a mistake or doing something wrong. And the operating system, too, has to prevent users from doing things like that, or making mistakes or changing things, then they won't work. So there's a lot of issues. Okay, so for week 3, we're talking about process scheduling. There's a lot of strategies that you learned about or went through in this chapter. I will highlight some of them. Again, do know on the office hours, I gave some practice exercises. And also a good strategy, as always, is to obviously read the chapter, look through the PowerPoint presentations, look through the videos, look on the internet for even more videos or material that you can then get a repetition of information so that it kind of, you get a better handle on it. Do the exercises at the end of the chapters. Some are assigned for your homework. Your homework, again, is always due on Saturdays, and then I grade them on Sunday. But if you turn them in early, I will grade them. But again, please do not pass out the answers to your fellow classmates because you're not really helping them. You're hurting them because this way they're not learning the material. Copy and paste, anybody can do it. Doesn't mean they're learning anything. So, this is our 3rd week, so hopefully after the first 2 weeks, you're comfortable with the classroom, comfortable with the process, and getting a better understanding of operating systems. Now, for this class, I do have to take attendance, so midway through, when we're about halfway through, I'm going to try to save that list again of everybody who's here. Last week, there was a glitch. For some reason, it didn't show everybody. But I'm going to try it again and see if everybody shows up. Again, if there's a problem where I didn't give you credit, but you were here, just let me know and I will change it until we figure out a better way or why there's that problem with Blackboard Collaborate. It maybe is a timing issue of when that list is saved that it reflects everybody. So that's something we are all researching on. And then again, but it's no problem. If you are here and by accident I didn't list you, do not take offense. Just email me and I will change it. And understand that it's just an issue with Blackboard Collaborate. Nothing personal to you. I'm loving that all of you are here. Thank you. Okay, so week 2, we went over the process concept and multi-threaded programming. So every week we're introduced into more and more detail. Week 1, we talked a little bit about process scheduling, and now in week 3 or chapter 5, we're going to go over it. Chapter 3 and 4 just went over some basics. So you're getting little by little. Again, the more you review this material, refresh your memory, and a lot of it you'll already know. When you go into chapter 5, things that are being talked about are some of the basic things we've already touched upon it. So here are the topics in chapter 3. Again, this is a good list for you then to have your summary or brief definition so that when you study for your midterm or final exams, you'll have a reference to go to. Also, during those weeks for those exams, I will be going over a lot of questions, example and practice questions and answers to help you as well for the exam or to study for the exams. And always know, contact me if you have any questions. And these are the information we went over chapter 4. Office hours, if you weren't here, we went over some questions and answers. So do look at the presentation slides in case you didn't, or you have those slides and the recording to go over again when you want to study or refresh your memory. When we get to week 8, which is a midterm exam, some of this stuff may be a little bit foggy because there's many weeks afterwards. So again, we'll start back with chapter 1 and review all the way up so that we're prepared for the midterm exam, and we'll do the same thing for the final exam. But it's a good idea for you to review the material. Every time you start a next chapter, go review the previous chapters and then start the new chapter so that you can reinforce the information you know. Okay, these are the basic topics for chapter 5. A lot of information here, a lot of strategies here. So you need to be familiar with the different strategies. You're starting to see some more calculations in this chapter, only because calculations are done in order to follow some of these or implement some of these strategies. There is a comparison made between processes. It's all determining when to process or let the CPU execute a process. So there's different strategies. But a good thing is, a way you can relate this, you can really relate this to your everyday life. Some people say the CPU is like the brain, and the rest of the body is the other parts similar to a computer. So think about it when you go through your day. How do you decide what you're doing and when you're going to do something? You do scheduling as well in your everyday life. And sometimes you do process a lot of things at the same time. So try to look to see what strategy are you using? Are you doing first in, first out? Or are you doing round robin? What are you doing in your everyday life? And you're probably going to choose a lot of strategies. For example, when there's an emergency, you pretty much are going to drop all processes and tend to that emergency. So actually, operating systems in the computer can be related to everyday human functions and everyday human processing, and try to do that. Maybe that'll help you get familiar with the different strategies by trying to see, are you following that in your own life? What are you doing? It would be great if it was simple that we could just do one task and get that task done and then move to the next one. Those were the simple days. I don't know when that was done, but maybe in history, long time ago, that's what everybody did. But nowadays, there's so many things going on, so many things we have to do, a lot of demands, a lot of responsibilities. So how are you handling them? How are you scheduling your processes? Or how are you scheduling the routines for your day? A good way then to get more familiar with the different schedule strategies. There's a lot of theoretical strategies as to if all of these are in practice. There may be one or two computers that use some of them, and most of the computers will use some other ones. So there are some examples for the main, Windows, Linux, and Solaris examples in the book. So take a look at them and see how they are actually using these strategies. And then anything that's real-time or embedded systems, those are specialized systems. Examples, like robotic machinery that's maybe in a factory. Those are a little bit different, and it's not something you and I typically use or you and I actually program. They always will come pretty much pre-programmed unless you're doing maintenance on these machines and you do work in some kind of a factory setting where you're working with these machines that have embedded chips in them and then are following some kind of scheduling of processes. Okay, so week 3, these are the materials to read. There are videos to watch. You're here in the required virtual class. Discussion question is out there. Yes, the discussion question is pretty much dry in the sense that it just has you list out what are the scheduling algorithms that are talked about in the chapter. But that's just a way for you to sit down and get to know them all. Perhaps by putting it in discussion question form or, typing it out in a document or in the forum helps you kind of clear it, because it can be overwhelming. There's a lot of information. But the more you try to make sense out of it, the more you try to list it, the more we discuss it, then the more repetition, the more information then you'll be able to retain. And then you have your exercises. As always, all exercises are due Saturday at midnight. If you do them before, that's great. Great strategy is to review the class material in the beginning of the week so that if you have questions, you can get them answered before the assignments are due. And also, the earlier you start, the more time during the week you have to devote to the material so that you have more time to understand it. The longer period of time you work on the material, the better you'll understand it and learn it. The shorter time, the less. So this is the discussion question, and it's just what are the various methods that are used to schedule processes. So some of you got a great start on that. Thank you. You're a great example to the rest of the classmates, and hopefully all of you will follow suit. with this information. Again, the more active you are in your learning, the more you will retain and the better you will learn it. You know, reading complex material sometimes can be overwhelming and it just won't sink in. So you have to use some other activity to help you learn it. Typing it out, writing it out, looking for videos. That's why after our last discussion on Monday, you were asking, this is so much material, how are we going to learn this? Are we going to be experts in this? And the answer to that is, first of all, know how you learn best. What type of learner are you? Are you one that can learn from reading, or do you have to hear it? Maybe you need an audio version. That's more how your brain works better. Or you might want to look for videos. So do seek out those resources that work best for you and the way you learn, and then you'll have a better and more successful experience with this material. So I did post some videos. Your classmate posted some videos, so please share some of the other resources you're using with your classmates so that you know it'll be a better learning environment. This is the one exercise. Again, you're going to be seeing some more mathematical calculations only because there has to be a way to determine all these algorithms and a basis for the algorithm so that they have some kind of process that's used to schedule the processes. So this was one exercise that was due, and this is the other exercise that is due. But I do urge you to look at all the exercises. It's good information, and it'll help you look at the different components and detail of this chapter a little more closely. And I think when you do an exercise on it, you just learn it better. So do go through that. If you need answers for those extra exercise questions, don't hesitate to contact me. By the time we're doing the midterm exam, I will be giving you the answers, and we will use that as part of our office hours and the virtual class to go over them. And I give you optional practice exercises as well, or questions. So use them as well to help you study for midterm and final exam, and also just for you to learn the material better. You want to actually know the material. It's not a matter of just passing the exam. Yeah, passing the exam is good for you as a student. However, knowing the material is better for you as an employee. So when you're going to be working, it's not a matter of passing a test. It's a matter of knowing what you are talking about and what you are doing. So learning this material is not just for the exam. It is for you as a skilled employee, that then somebody who hires you will know you know your material. So even after class is done, this is material you should still keep refreshing your memory about, and also looking for the latest research that's being done in that area so that you are on top of it. When you are working for someone, you know what's coming. You know what's going to be in the future because you're still learning about it. I don't think you should ever stop learning because especially in the computer field, everything continually changes. It always gets better. And this is something you need if you want to be an IT professional, something you need to continually learning. So join organizations. Maybe there's an organization at your school where there are professional organizations. There are international organizations. And these organizations are the ones who set the standards that are used in the workplace. So joining these organizations is a good way to learn the new stuff as it comes out. Okay, so chapter 3. Any questions so far about anything? Are we all good? But I'm giving you a little motivational speech more than I am the material, but I'm just talking from someone who's in the field as a professional for many years, that's just how it works out there. And also know that you can work with mostly anybody as an IT professional will always have a group of colleagues or networking professionals where they can talk with each other. That's how they learn new information. because you got to keep learning. You can't take a class every time something changes. You know, you get the new Windows operating system. Does that mean you're going to go back to school to learn it? No. There's going to be a new software product that's out there, a new version of Microsoft Office coming out. Are you going to go back to school and learn it? No. You're going to have to learn how to learn on your own. And these organizations or your networking with colleagues is a way then to learn this information. So you have your classmates here that are going to be somebody you can refer to and reference as well, or contact in case, you know, find that group where you can keep learning as a study group even though you're not in school. Okay, CPU scheduling. The success of CPU scheduling depends on observed property of processes. So we have process execution consists of a cycle of CPU execution and I/O wait. So there's those are the main things. I mentioned that before. The CPU goes really fast, but it's waiting to get stuff from input or output to it so that it can go on to the next instruction. That is something that I've mentioned many times before, and the CPU is faster than anything else that works on your computer because all the technology is just not there yet. But because there is this waiting element, it has to be factored into any kind of scheduling. And then we have what is known as a CPU burst and an I/O burst. Again, we just have a machine that clicks. There's a clock that ticks, and it's within these cycles. Every time it clicks, the next cycle continues. So you can consider them as bursts. A lot of terminology can be used, but typically you have a CPU burst and another I/O burst and so on. And that continues until the process is done executing. So these are the basic concepts. This illustration is in your textbook as well. But it is how the computer works. So all scheduling algorithms have to be centered around this. It's a way of making sense and having some logical order to the way the computer works, so you can use this logical order when you're creating programs. You need to have logic, and you need to have some kind of constraints. These are like constraints in the sense that these are what you're working with. This is your domain, and the constraints are how the CPU burst works, how this I/O burst works. And here's another image that's from your textbook. Gives you an idea of CPU burst times. It's just a visual representation. But again, it would depend on how fast your CPU is, what your burst time is. They do vary. That's a good area you can research is how do they vary between CPUs? How does the burst time vary between the different CPUs that are on the market today? And then we have that short-term. There's a long-term and a short-term schedule. Typically, it's the short-term schedule that's working. And again, it's a matter of just making sense out of all the processes that need to be executed. And these processes are using the computer resources. And one of the resources of the computer is the CPU. So it's a matter of which process gets which resource when. And it's making sense out of it all so that a program can be run, and we as computer users then can use our computer to do something. So whenever the CPU becomes idle, the operating system must select one of the processes in the ready queue to be executed. I do have a little video on the announcements page that kind of simulates with the tick of a clock when these processes are put into the ready queue and when they're taken out to be executed. So do look at that video. It just gives you an idea. It's like a heartbeat. Again, it's similar to how our body works. The computer is an extension of, a lot of calculation that we do mentally with our brain. So we try to emulate that, and we try to get the computer to do things that we used to normally do, but now we use the computer to do it. The great example is accounting. Before, a lot of accountants had to write on paper and pen and manually do calculations. So now we have a computer that does it. So it's a matter of using the computer so that we can do our real world stuff, but we need that operating system to manage it all. Again, we're going through process management. We're going to talk about memory management. We're going to talk about device management. Those are the different management. User management. So this is just one of the areas that the operating system manages. And it's probably a very crucial one because the whole ultimate goal of using a computer is to process something. So the short-term schedule or CPU schedule, the scheduler selects a process from the processes of memory that are ready to execute and allocates the CPU to the process. So it's a matter of how do you determine which process to process. There's so many that need to be processed. So this is what came up with all these different algorithms. But again, try to liken it to what you do in real life. What do you do when you have so many things to do? How do you handle it? Do you make a list, which is similar to a queue? Or do you do one at a time and forget the rest? So what is it that you do? How do you handle your own tasks and processes? And that's just a way to visualize how these strategies work in the real world or for the computer. So we have different ones we're going to look at. We're looking at FIFO, which is first in, first out, priority queue, a tree, unordered linked list. So there's so many different, but we know the basics. We know we have a process. We know there's a process control block that contains information about that process, and we know that process is put into a queue getting ready to be in a ready state to be passed to the CPU. This we already know from chapters 1, 2, and well, for weeks 1, 2, and 2. So now we're looking at, well, what really happens when we're dealing with these processes. Things that are looked at. This is why we have to come up with scheduling strategies, because we want to make sure that the CPU is always busy and working. Again, I don't think we match yet the speed of the CPU, unless you have some sophisticated type of supercomputer. But really, the most of the time is getting the information to the CPU, so the CPU does sit there and wait more time than it should. Throughput, number of processes that complete their execution per time unit. Of course, we want to get as many done at the same time as possible. Turnaround time, amount of time to execute a particular process, waiting time, response time. So these are all elements that are looked at when coming up with a scheduling strategy. They vary too, depending on the purpose of your machine. Some of these may be more important than others. So some items might be put on the back burner and not addressed. So it all depends on what your machine is doing and what its main purpose is. We'll determine which one of these are at the most optimal. Can you have them all optimal at the same time? Well, that would be a perfect world. And I don't think we have a perfect world yet. So that's where consideration has to be made, and that's why there's so many different algorithms for these scheduling, because sometimes one of these items is more important than another depending on the situation. And that's just emulates life. So in life, we go through life, some things are more important than others at a given time. Now, can we have one major or main operating system that could switch all of these whenever needed? Again, that would be a perfect world. These operating system programs are complex. To have one that incorporates all these strategies and it just is so smart that it knows which strategy to use one, that is something for the future. So these are the optimization. Max, we want max, max, min, min, min. So these are the areas that a lot of these schedules are based around. Only because that kind of works for most situations. Okay, first come, first serve, just like the name suggests. If you think about the terms and the titles for these schedules, will kind of give you a clue as to how it works. So first come, first serve. That means whatever comes in is the process that requests the CPU first is allocated the CPU first. When a process enters the ready queue, its PCB, process control block, is linked onto the tail of the queue. Now remember, when we talk about the operating system, we're talking about programs. And when we are talking about programs, we have to reference the different data structures that are used, because this is programming code. So a lot of these descriptions of these schedules related to the data structures and the code words that are used in the program itself. So depending on how much you have an understanding of programming or if you have programs, you will then have a better, an easier time relating to these descriptions, because it all comes down to how it can be programmed, because the operating system is a program. It's not anything else. So when you're talking about ready queues, when you're talking about linked tail of the queue, this is all similar to a linked list and data structures for programming. So a good way to understand all of these is to understand data structures. So I think you have taken that course or will be taking that course. So go back, if you're not familiar or remember some of this, go back to your program, your data structures information and material. And then if you can visualize the program, then you can visualize the logic. And once you understand the logic of the program, then it right away gives you the idea of the logic behind the scheduling algorithm. Algorithms in general is programming code. It's the logic used prior to creating program code. Okay, so this one is a simpler one. Shortest job first scheduling. So again, as the name suggests, the shortest job, the first one is scheduled. Okay, so if you have any questions on any of these are just brief descriptions. Priority scheduling. So in other words, you have some priority. So even though something's processing and it's low priority, and a process comes in that has higher priority, well, then the higher priority then is scheduled. Now, depending if it's scheduled next, or if it's scheduled and then the low priority is interrupted, that again, different strategies. Again, this all just relates to different ways to write a program. You have information coming in, your input is your process, and then you need to pass this information to the CPU, and so on. Round robin. This is where you go through each process a little at a time. You do the first process for a little bit, then go to the next process for a little bit, then the next process for a little bit. But that management is a little hard. You got to keep track of where you are with each process and make sure you do them in order and don't mix up the data from one process to another process. So as you look at these schedules too, you can think about the programming code, and it's a little bit more complex because the more things you have to keep track of, then that adds to the complexity of the program. So the round robin, and depending on how much it processes, are just some calculations and determinations that are made. Then there's multi-level queue. This is where the different processes, depending on the kind of process they are separated. Some are for the foreground processing, some are for the background processing. Some are allowed to wait because they're not that important. So multi-level kind of has an inherent priority or characteristic for a process to determine if it's in the foreground or the background. But I think you already see this with multitasking. You know, sometimes there are some processes that run in the background and some that run in the foreground. And also this allows you to use different schedules. For example, the foreground queue might be scheduled by a round-robin algorithm, while the background queue is scheduled by a first-come, first-served algorithm. So it allows you now to have a little bit of each, different strategies together. Because we know one specific algorithm is not the best for all possible situations, because as life is, there's always different types of situations. And I think when you go through life, you experience this yourself. You're not always going to do the same thing all the time for everything. You have to change the way you do things. You have to change your strategies. Same thing with the operating system. So this is a diagram for the multi-level queue scheduling. Okay, I'm going to just stop right now, and I'm going to save the participants. So hopefully everybody here now will get on this list, and it will be reflected when I then do your grading. Again, if this list doesn't work properly, then let me know you were here, and then I'll update your grade. Okay, so it saves, and hopefully you're all here. If anybody comes after this, let them know that they need to let me know. Okay, multiple feedback queue. Again, this allows for different queues and also the ability to do different algorithms depending on the different queues. So it gives you more opportunity to emulate different strategies and different scheduling. But again, the more variety or options you have in a scheduler, the more difficult it is to program it. And the more difficulty there is to program something, the more possibility for errors and the computer will crash. So when programs are written for these different varieties, it's very important that testing be done to a very detailed level, because you never know what can happen and what processes are coming in or what users do. And there has to be a lot of safeguards, and there has to be a lot of testing to make sure when I do have these different algorithms, say for the foreground queue, I'm using round robin, and for the background queue, I'm using first come, first serve. And while I'm processing it, I don't confuse the two and later start doing round robin for the background queue and then use the first come, first serve for the foreground queue. So it has to be very logically, carefully detailed when it's programmed. Threads, we looked at threads, and threads you'll have more opportunity to experience because we already looked at kernel threads, user threads, and also something that we can program. Threading can be done as we looked in Chapter 4, threading, multi-threaded programming. It's a very popular item that's done, and it's something that a lot of programming languages will allow for. So you can do some detailed programming as a user to manipulate processes. Now, what if you have more than one processor? Again, the more sophisticated our computer systems come, the more algorithms and scheduling we have to add. Operating systems have to keep changing to address the new technology that comes out. We can't use that old single processor, single user strategies anymore. That's not the case. We kind of transitioned to multitasking, and now we're using multiprocessing, and it's on a higher scale. There used to be a time you would only have specialized companies using multiple or parallel processing machines. But now you're seeing those dual-core processors, those quad-core processors coming to everybody's life. So it's all on a massive scale. So yeah, there's a rush to get these operating systems functional and keeping up with the technology. So if you like this kind of stuff, if this complexity and sophistication is a challenge you really like to do and can't wait till you get and learn about it, then yeah, then you would be a good systems programmer. Again, remember I mentioned there's two areas, systems programming or applications programming. The systems deals with this kind of stuff, and it will deal with adding to existing operating systems so that they can handle this different hardware that's out. Application programming, that would deal with the real world stuff. And then there's a whole other world of networking, because everybody networks. So we have an area of networking programming and the web pages and all that area. So it all depends. Each one has their own level of sophistication and their own level of complexity. So it's a matter of how deep do you want to get into this programming. To be a systems programmer, you have to be very detailed and attention to detail. And because we already know the complexity of the operating system is you can't make a mistake. In an application program, yeah, you should make mistakes too, but the computer still runs even if you make a mistake on your spreadsheet. The computer will not run if you make a mistake in the operating system. So that's simple, the level of attention to detail you need. So what happens when you do with multiple processors? There you go. Here's some strategies. Do you know about it? Asymmetric or symmetric. How are these processors processing? Again, simulated to the real world. Well, if I have these things working, what are the different ways I could use them so they're working? Well, I can have them work separately. I can have them work together. I can have it where even if they're working, I can interrupt them. Or even if they're working, I can't interrupt them. Again, so just kind of related to the real world. How do things get done in the real world if you have all these different components? And maybe that'll help you, give you an easier understanding when you start working with this terminology. Now, real-time systems, very important. These are a lot of manufacturing ties to real-time. A lot of industries, real-time transactions, real-time robotic machinery, when you're going through an assembly line, when you're running a nuclear plant, when you are airline industry. So there's a lot of real-time processing in the medical field. A lot of real-time. It should be more real-time. If you are, seeing a doctor, well, the other doctor or somebody, the hospital should know all your information. If you go into the hospital, all your information should be on the computer for anyone to access, because if you are in an emergency situation and need to be tended to, your whole history should be accessible through the system. So this is a lot of real time, and anything input into the system should be then automatically added to the information so the next person that comes in has the latest and greatest information. So again, we know that everything in life, not everything needs to be at this kind of sensitivity or time sensitive, but some things are, and if they are, we have to be able to deal with it. And this is where you have your real-time CPU scheduling. So you have soft real-time systems, hard real-time systems. Soft is no guarantee as to when critical real-time processes will be scheduled. Hard is where the task must be serviced by its deadline. Again, it all depends on what kind of system you're dealing with and how dramatic are the effects if something is not done on time. Priority-based scheduling. So for real-time scheduling, the schedule must support preemptive priority-based scheduling. In other words, preemptive meaning it can be stopped or switched out or changed, and there's a priority there to determine. If an emergency situation comes in other words, there's a machine that's getting too hot and it has to be turned off really fast, that would be by preemptive priority. In other words, if that comes in, and even though something else is running, everything has to be stopped, that has to be addressed, and the machine has to be turned up. Otherwise, it's going to blow up. So that's typically your more serious real-time situations. So the processors have new characteristics. Periodic ones require CPU at constant intervals. So again, it's just a matter of strategies that you're dealing with depending on the environment and the situation you have. That's why you have all these variations? Because life has all these variations, bottom line. Then there's virtualization and scheduling. Virtualization software schedules multiple guests onto CPUs, each guest doing its own scheduling. So these are your virtual, your VMware would be an example of that. Then there's the rate monotonic scheduling. There was a question about that one. This is just a way to, again, come up with an algorithm that for most of the time will work, because you will have priority processes, and again, it's preemptive and priority based. But the algorithm here adds another dimension in the sense of, well, we know these processes have to get done. They have a time as to how much they need, and they have a deadline. So the scheduling tries to put in as many processes as it can so that they get completed within the time allotted. I don't know if that helps here. So a priority is assigned based on the inverse of its period. In other words, shorter periods have higher priority because they know it can get done faster. So let's get all the shorter ones first, the longer ones lower, because it'll take time with the CPU. Earliest deadline first scheduling, another strategy. Proportional share scheduling. So there's a lot of strategies. Hopefully you will go through them. This is a list of them with a brief description. But one thing that'll help you distinguish or understand them in better detail is to go to the exercises at the end of the chapter. That'll give you a way then to actually address each one individually. Some of the questions will compare a couple of them together, but that's the best way to get some more detailed knowledge on these different schedules other than this brief description. I think the brief descriptions, if you just look at the name of the schedule, you kind of can get a guess as to what it does. I mean, first come, first serve. Just by its name, you kind of understand what it means. Round robin, just by its name, you kind of understand what it means. That rate monotonic, RMA, that is, if you think mono means one. What that does, it kind of has a standard for how long your CPU burst is. And it's going to try to get as many processes in there depending on how long this burst is. So there too. So everything by the name kind of gives you a clue as to what it is. And again, if you complete those exercises at the end of the chapter, and also the optional practice exercise I gave you within the office hours will help you as well. And then towards the midterm exam in week 8 and week 14, we'll go over a lot of the exercises for you and give you the answers and discuss it. So if you have questions, you know, you can ask them now, or maybe if you don't have the time now to go through everything, you'll have another opportunity. Again, we will revisit this material again and again. And then the positive real-time scheduling. API, right away when you think of API, you think of programming languages. So it's functions for managing real-time threads. When you see threads, right away you should think of programming. And programming that you will be doing. We'll be looking at some of this stuff. Operating system examples. Do you know the differences and how they do? Again, this gives you another illustration between the different schedules and how they're actually implemented. Again, it's not a, you know, we don't have just one ideal operating system that does all schedules and does the right schedule at the right time, depending on what process is coming through. These are complex programs, and operating systems will implement these programs as they can and as they feel is the most frequently used one. So any questions so far? There's a lot of material. Again, it's just a matter of you just have to know it and study it. So any questions? Okay, so again, we have our meetings, just to recap, and then I just wanted, in case you got this all done and you want to work ahead, this is what's coming up in week 4, chapter 6 and chapter 7. There's also an article that you will read and have to discuss, and you have a video. And here's the exercises for week 4. Again, we are in week 3, even though I'm giving you week 4 ahead of time in case you want to work ahead. But that's exercises 6.1 and 7.8. Also, you will be discussing your first programming project. And that would be programming project, the Sleeping Teaching Assistant. So hopefully, the material, again, it's just a matter of learning it. There's no easy way to learn it except to do it. Try to relate it to your real life and how you access and do processes and do your tasks and jobs in life to help give you a glimpse of these different strategies. Maybe you can identify yourself some of these different strategies and scheduling you're going through as you go through your day. Also, make sure to go over the exercises at the end of the chapters. We will have time when we will revisit this. Again, office hours, we'll go through questions and answers. Virtual session, we'll go through material. And if you have any questions, don't hesitate to contact me or your classmates. And I think that's it. So hopefully I have you down in the participation list. Again, as I graded, if I missed you, please send me an email. Let me know. Again, I don't know the timing. I think if you get here on time, midway through, I will always do the saving of the list, and hopefully we'll have everybody on there. If you come after midway through, then let me know, because then you won't be on the list. And have a great day, unless there's any more questions. Thank you. And hopefully we'll make our virtual sessions a little more exciting once we get some more exciting information. But I think just hearing it again and again is a way then to hopefully learn it and get it to stick in your mind. You read about it, you looked at your material and your resources, you heard about it again from me, you saw it again on the slides, and then we'll go through questions again through the office hours. Now, have a great day. And again, I'm letting you out a little bit early because now you have that extra 8 minutes to do some studying. So it's not like you're not here, but you're just doing independent study and research. And again, thank you for the wonderful support you are adding to your classmates. It's a warm environment. And I think everybody feels very comfortable to ask questions and to just offer their information and share their resources. Again, there are example videos out there. So when you find something that really was cool for the material, share it with your classmates. It'll just make it that much more fun. And again, have a great night, I should say, not a day. It's evening for you. Thank you, and enjoy. Remember, education is a good thing.